multiplying radicals. Let's see 1. Remember when we add two like radicals, when we add or subtract radicals, we need like radicals. But not for multiplication and division, just like dealing with variables. When we add variables or subtract variables, we need variables to be like terms, right? We need the terms to be like terms. So similarly, when we add or subtract radicals, we need the radicals to be like radicals, which means the index the same, the radicand the same. But when we multiply and divide, no, we don't need like radicals. So how do we multiply? As long as the index are the same, we can put the radicands under one index. Let's see number 1. We have square root of 6 times 4 times square root of 6. So one way we could think of this as 4 is a number, is not a radical number, right? 4 is just 4. But we have radical 6 times radical 6. Because both is under the index square root, so we can put under one radical sign. Well, 6 times 6 is 36. Square root 36, we know it's a 6. And also we can think 6 times 6 is 6 squared. Square root of 6 squared is just 6. Because square and square root cancel each other. So just get 4 times 6, 24. So the answer for the first one is 24. Or another way of thinking of this question, right? So what is this number? What is the square root of 6? Square root of 6 exactly means when you square this number, you get a 6. Right? When you square this number, you get 6. And exactly, we do have another square root of 6 here. So see this one, you could think as a 4 times square root of 6 squared. You can put parentheses around or without parentheses around. So this power 2 and the index 2, or index 2 is invisible by default. 2 over 2 is 1. If we read it as a rational exponent, right? Remember how do we read irrational exponent? 4 is just 4, we just keep writing it. And 6, radicand 6 is raised by power 2, and it has an index 2, right? We call this a rational exponent. Rational, oops. Rational exponent. Rational means a fraction. What does fraction mean? Fraction means the numerator is an integer, denominator is also an integer. So we see 2 over 2 is 1. That's 6 raised by 1 is 6. So 4 times 6, 24. So you have, different ways of thinking about this. But in order to emphasize square root of 6, when you square it, it's a 6. I'm going to keep using this idea, okay, to square it. Let's see 2. We have negative, we have positive. So negative times positive is negative. So first we deal with the sign. Then we have square root of 5. No, 20 can be split into square root of 5 times square root of 4. Okay. I can write as with the 2 radical signs. So square root of 5 times square root of 4. Now, do you see we have square root of 5 times square root of 5, which is a square, which just becomes 5. What's the square root of 4? Yes, the 2. So negative 5 times 2, negative 10. Now let's see 3. Maybe you can do 3 faster than me now. Negative times positive, negative. Square root 2 times the square root of 3. Same index are all 2. So we can put them under a single radical. What's 2 times 3? 6. So we'll get a negative radical 6. So this is telling us radical 6 can be split as radical 2, radical 3, right? Yes. You can split into the radicals of the factors of a number. Let's see 4. 4, I have a number 4 outside. Now, inside the square root, the radicand, I have 8 times 2. What's 8 times 2? 16. What's the square root of 16? 4. What's 4 times 4? 16. So for number 4, the answer is 16. If you remember, square root of a is 2 radical 2, right? So if, yeah, I can do this way. So square root of a is 2 radical 2. And now I have radical 2 times radical 2, I have radical squared, which becomes 2. Then times this 2, that's 4. 4 times this 4, that's 16. Let's see this 4. So 5. 5. First, I can put them under the same radical sign. I have 12 times 15. 12 is 3 times 4, because I'm looking for squares. I'm looking for 2 same radical numbers when the square becomes a number. And 15 is 3 times 5. Right? Now I see 2 squares. 4 is 2 squared. 3 is 3 squared. 2 times 3 is 6 squared. So that tells me I can split it into square root of 36 or square root of 6 squared times square root of 5, which is 6 radical 5. This is 6. Positive times negative, negative. Let's deal with the sign first. Then I have number 2. Radical 5 times radical 5 is radical 5 squared. Remember, what is it? It's just 5, right? Radical 5 times radical 5 is just 5. Negative 2 times 5, negative 10. Let's see 7. Negative times positive, negative, negative 3 right up front. Then 20, we can think as a 4 times 5, right? Square root of 4 is 2, so negative 3 times 2. And I have square root of 5, square root of 5. Square root of 5 times square root of 5, that's just 5. 2 times 5 is 10, 10 times negative 3, negative 30. So the answer for 7 is negative 30. Let's see, 8. 15 can be split into 3 and 5. So I have square root of 3, square root of 5. Then now I have this square root, I have 2 square root of 5 multiply each other. So I get a square root of 5 squared, which just becomes 5. So I have 3 is this one, times 5. But I still have square root. This is square root of 3 here. I still have square root of 3. So 3 times 5, 15. So the answer for 8 is the square root, is 15 square root of 3. 15 times square root of 3, or 15 of square root of 3. Let's see these two. If you can do faster than me now. Square root 9, we know, it's just 3. 3, radical 3 cannot be simplified. So that's just 3 radical 3. If we do multiply 9 with 3 under the square root, we'll get 27. Remember what's the square root of 27? Indeed, 3 radical 3. Let's see 10. 10, 8, we can split into 4 times 2. Right. So we have square root of 4, square root 2. Or if you remember square root of 8, we should remember square root of 8 is a 2 radical 2. All right. Square root of 10 can be split into square root of 2 times square root of 5. Now you see we have square root 2 times square root 2. These two become square root of 2 squared, which just becomes 2. Square root of 4, of course, is a 2, but we had -4 in the beginning. So then what's left? We're left with the square root of 5. So 4 times 2 times 2, 4 times 4, -16. So the answer for 10 is -16 square root of 5. Right, so it's just an irrational number with square root of 5, in between 2 and 3. We can approximate, but we don't want to because we're doing pure mathematics. We can keep as -16 square root of 5. As I said earlier, we need to make friends with this with this irrational number family. Now let's see division. How do we divide two radical numbers? We need to have the same index for each root. So we check 11 is both the numerator and denominator both under square root of 2. So we can put them together. Why we like to put them together? Because sometimes if we put them together under one square root sign, they can be simplified, right? But this one, let's see, we know square root of 8 is 2 radical 2, right? So the 2 comes out, which means, but we have 7 as a denominator. And so we have 2 times square root of 2 over 7. And a lot of time, we don't like to keep the denominator. Let's see if I rewrite this right. I read it as 2 radical 2 divided by radical 7. We don't like the irrational numbers appear in the denominator. Let's see why. Right? I have 2 radical square root 2, some apples shared by square root of 7 people. You don't want to see that, right? Square root of 7 people means you must have to cut one person. You have 4 people. You have to cut one person in portions. So that's why we don't like irrational numbers appear in the denominator. We want to make the irrational numbers to be rational. Right? In this case, we want to make a square root of 7 to be 7. How do we do that? We just multiply by itself. But we can only multiply by 1. So 1 is a transformer. It's just something divides itself. In this case, it's a square root of 7 divides itself. So then the denominator becomes rational number, becomes 7, right? Something shared by 7 people always makes sense. Then the numerator will have 2 square root. So square root of this 2 is a prime number. This is a prime number. 2 prime number multiplied. We don't have squares inside. 2 times 7 is 14. So for 11, the answer is 2 radical 14 over 7. And sometimes we write it even this way. 2 over 7 of radical 14. Right? Remember, the numerator can be written in the numerator or can be on the side. So sometimes you may see a number like this, 2 over 7 square root of 14. It's exactly the same as this one, 2 square root of 14 over 7. Now let's see 12. 12, numerator will have 7, denominator will have 8 radical 7. All right, all we have to do is to rationalize the denominator, which means make the denominator a rational number. Again, we multiply by square root of 7 or radical 7 over itself. Then this becomes radical 7 squared, the denominator. So it's just 7. 7 times 8, 56. So the denominator is 56. And the numerator will have 7 times radical 7. Numerator can be irrational numbers. Okay, that's for 12. Let's see 13, 14. It's both a square root, so we pull them together. 2/6. Now you see the reason why we want to put them together, because this one can be simplified to be 1/3. But what does this mean? Square root of 1/3. It means 1, because remember, 1 raised by any power is still 1 with the square root. So 1/, square root of 3. Now we want to multiply by 1. This one is the square root of 3 over itself, because we want to rationalize the denominator. Then we get radical 3 times divided by 3. Let's see 14. Again, we can put under single one. So I'm going to just do this, okay? I can put under single index. So 21, I see 3 as a common factor, right? So numerator can be simplified as 7. And denominator is 3 times 5. So I have radical 7 divided by radical 5. I want to rationalize it. So I multiply by another radical 5 divides itself. I want to rationalize the denominator. So the numerator I have radical 7, radical 5, both prime numbers. I just multiply them. They're different primes, right? There's no square in it. And denominator is radical 5 times radical 5. This is radical 5 times radical 5. This is 5. So number 14 is square root of 35 or radical of 35 over 5. Sometimes maybe you see this can be written as 1/5 square root of 35. Just like when we write, 1/5x. Or we can write as x/5. So similar argument. Now let's see 15 and 16. So here we want to multiply by square root of 7 divides itself. Then the numerator will have a square root of 3 times square root of 7. That becomes square root of 21. Because 3 is a prime, 7 is a prime. We just multiply those two. And denominator, we have square root of 7 times itself becomes 7. 6 times 7 becomes 42. So keep in this case. 16, we want to multiply by now, you probably know we need to multiply by square root of 3 divides itself. Right? Square root of 3 times square root of 3, that just becomes 3. And the numerator is square root of 5, square root of 3, 2 prime numbers. Again, we just multiply them under the square root sign. And the denominator is just 3, or 1/3 of square root of 15. Let's see 17 and 18. So 17, yeah, it can be simplified a little bit if you can see it, right? You see numerator I have square root of 15, denominator I have square root of 6. So under the square root signs, 15 is 3 times 5, 6 is 2 times 3, right? So this simplified to be 5/2, because 3 is a common denominator, common factor of the numerator and denominator. So the numerator simplified to be square root of 5. The denominator simplified to be square root of 2. Then we want to rationalize the denominators. We multiply by square root of 2 over itself. Basically, we're multiplying by 1. Right? Something divided itself is 1. Now, the numerator is just 5 times 2 to the square root of 10. We know cannot be simplified because 2 and 5 are prime numbers. Denominator will have 3 times 2, which is 6. So square root of 10 over 6, or 1 over 6 of square root of 10. Let's see, 18. 18, sometimes my mouth goes ahead of my brain because I see this 8, this is 7. And this, we know square root of 8 is 2 radical 2. Right? Then we see this 2 simplifies 2 in the denominator. So this is simplified to be square root 2 over square root of 7. Then we need to multiply by, what do we have to multiply? To rationalize the denominator, to make the denominator a rational number, we have to multiply itself. So square root of 7 in the denominator, we'll have to multiply by another square root of 7. Then we'll have to do the same for the numerator. So now the numerator becomes 2 times 7, again, 2 prime numbers. That's just square root of 14. Square root of 7 times itself, it's just 7. So the answer for 18 is the square root of 14 divided by 7. Or sometimes you can write as 1 over 7 of square root of 14. Okay, that's it. So this video is for multiplying and dividing two radicals.